Hopefully this is working here. I'm gone today, 6th hour. I know you're very upset that I'm not going to be here today to teach you, but I'm just going to do a video just for today so you can watch this and then get working on your assignment. Be good for Mr. Blessing today. All right, so today we're going over properties of real numbers. Remember, real numbers are, every number we're going to talk about here for the foreseeable future. We're not dealing with imaginary numbers for a while. Yesterday we talked about these. Okay, these are all real numbers. They break down into rational and irrational. Remember, rational, right? They can be either the decimal stops, or if it has a decimal, it repeats. Irrational, if you put it as a decimal, it's not going to repeat, but it will go on for forever. Integers are all the non-decimal numbers. Whole numbers are all the non-decimal numbers, not counting the negatives. And then natural numbers are your counting numbers, starting at 1 and then 2, 3, 4, and so on. So just a little refresher from yesterday. We're going to talk about properties. We'll talk about these periodically throughout the year. We're going to use them to solve different equations, do some different things, so it's good to be familiar with them. So we'll start with identities and inverses. So identities, what happens with an identity is, you have a number, say n or 5. You're going to add something to it, and you get back to where you started. Okay, it keeps its identity is one way to think about it. So additive identity property just says if you have a number, you add 0 to it, well, you end up with the same number. Okay, n plus 0 is going to be n, no matter what number it is. 5 plus 0 going to be 5, no matter what. Okay, multiplicative, same concept, but with multiplication. So if you have n, if you multiply it by 1, okay, or if you multiply it the other way around, you end up with n. Okay, essentially anything times 1 equals what you started with. Okay. Then we get to inverses, which can be a little more confusing. Okay, for an additive inverse, it's what you add to the number to get to 0. Okay, an additive inverse is always just the opposite sign. Okay, anything plus its opposite sign number gets you to 0. So n plus negative n is 0. 3 plus negative 3 is 0. If you have negative 3, you would add 3 to get 0. So I guess I kind of gave away this answer. So what's the additive inverse of negative 3? Okay, so what's the opposite of 3? Positive 3. That's the additive inverse. Just change the sign. Multiplicative inverse. The goal here is to get back to 1. This one we'll use quite a bit in solving problems. So multiplicative inverse is kind of what you, well, maybe not what you think of it as, but it's the reciprocal. Okay, any number times its reciprocal is going to get you 1. Always, no matter what. So the reciprocal of n is 1 over n. Reciprocal of 6 is 1 over 6. You multiply those, you get 1. So what's the multiplicative inverse of negative 3/8? Well, the reciprocal of that, we notice we're not changing the sign this time, is negative 8 over 3. Okay? If you want to check it, okay, negative 3 over 8 times negative 8 over 3. Well, what happens to the signs? Negative, negative, positive, right? 3 times 8, 24. 8 times 3, it's just switched around. 24, and you get 1. So if you're ever asked for a multiplicative inverse, it's just the reciprocal. If you need an additive inverse, you're just adding the opposite. Other properties we have, first is this closure property. This doesn't come up a whole lot, but it's good to be familiar. It says the sum of a product of any two real numbers is a real number. Right? If a and b are real numbers, then this is true. Okay? All this means is, these are real numbers, right? So a plus b, if they're real, you're going to get a real answer. If a times b is a real number, or if a and b are real numbers and you multiply them, you're going to get a real answer. Essentially, it's saying that if you add two real numbers, you're not going to get an imaginary number. Okay? Or multiply two real numbers, you're not going to get an imaginary number. That's all the closure property means. If you do something with two real numbers, they stay real numbers as far as products and multiplication go. Again, not going to use this one a ton. Next is commutative. We have both addition and multiplication. So you can do a plus b. It's the same thing as b plus a, right? A times b is the same thing as b times a. Essentially, it's telling you can change the order in which you multiply or add. Associative property. This always deals with how you group things, okay? Someone once told me to think of your associates, okay? Who's your group, right? So if you have addition, doesn't matter where you put the parentheses. Doesn't change anything. You can put them around A and B, you put them around B and C, it's still going to get you the same answer. Same with multiplication, okay? The parentheses can move when it's all multiplication, doesn't change a thing. Distributive, you should all know that one, okay, right? A times B is AB, A times C is AC, right? Okay, distributive property. Works if it's at the end too. No difference there. All right, so identify the property. So number 1, 6 times 1 equals 6. Well, it's staying the same, right? Times 1 by anything, you always get the same thing. So we're multiplying. We have the multiplicative identity. We're staying the same. Sorry, my handwriting might be a little tough to read. Okay, next, okay, notice the parentheses. We're grouping things differently. So that would be the associative. And we're going to say property of addition, right? Because we're adding. So make sure you include that second part. Here, okay, yeah, there's parentheses, but what's actually happening? We're doing 3 times A, 3 times 7. So you should recognize this as the distributive property. Okay, then down here, what's happening? Well, we're multiplying, right? We're switching the order. Okay, when that happens, hey, that is our commutative property. In this case, of multiplication. Down here, hopefully, you notice that this one and this one are reciprocals. When you multiply by the reciprocal, you get 1. So here it's the multiplicative inverse property. So you need to look at problems and know the properties. All right? All right, these fun sometimes, always, or never trues. So, the directions should be obvious, as it's sometimes, always, or never true. First thing I like to look at is a property happening here? If it's one of our properties, then it should be always true, right? A plus negative A. Well, that has to be 0, right? That would be our additive inverse. B plus negative B has to be 0. And 0 always equals 0, so this is always. And if we're going to, if I could write, explain ourselves, we're going to say always because of the additive inverse property. Okay, next. Not really any properties going on here. So then, okay, you think, can this possibly be true? Can I think of an example where it works? Can I think of an example where it doesn't work? So the one that works here is if A, B, and C are 0. You would get 0 equals 0. Where it wouldn't work is, say, 1, 1, and 1. Okay? Then you would have 1 minus 2, which is negative 1. This would be 0 over here. They don't equal. So sometimes. So if you're going to do a sometimes, you need to be able to think of when it would work and when it wouldn't work. Here, 8 times B equals A, when B equals 3. So if B is 3, what times 3 equals itself? Any ideas? I could think of one. How about 0? 0 would work. Anything else doesn't look like it's going to work. If B is 3, it's not going to work out. So it's sometimes. And I'm hoping the second one should be pretty obvious. This is an always by the distributive property. So pretty simple stuff. All right. Oh, nothing's on the next page. So there's your assignment today. Get as much done in class as you can. You should be able to do most of it, I would think. And I will be back tomorrow to answer your questions. Hopefully you got 1.1 and 1.2 done by tomorrow. I will be doing a homework check sometime next week. So